In this lesson, we're going to use Node.js to create a basic web server. So first, let's visit what Node.js is used for. It's used to create server-side applications in JavaScript. So historically, conventionally, JavaScript was used to create client-side applications. It runs in a web browser. We put some JavaScript between some script tags, and then the browser interprets that JavaScript. And that's how JavaScript was used for a long time. And other languages and frameworks were used to create the server-side applications that our clients interact with. So Node.js quickly became a popular way to create server-side applications in JavaScript, and that is how we're going to use it in this lesson. So to create a web server, we should understand what a web server does. Basically, a web server is used to store, process, and deliver data through the internet to some clients. And the protocol that we use to do that is HTTP, or secure HTTP. And the way that this works is that the client and the server talk to each other. The client sends requests to the server, and that request will be one of a certain type. And we refer to these types of requests, refer to the verb, the HTTP verb, or the method. And the ones that we're going to talk about are the ones that are on the screen here. So we use post if we want to create a resource from our client. We use get to read a resource, put or patch to update a resource, and delete to remove a resource. And we saw how we used these verbs or methods when we did our Rails lessons. And we have the same things available to us now to implement in JavaScript. Now, with Rails, we got a pre-configured web server. We used Puma. And what we're going to do today is create our own web server in Node.js. And you'll see that this is, there's a bit of work here. There's some things we have to do, and we really need to understand what it is a web server does to be able to implement a web server in Node. So it's going to be great. We're going to learn a lot. In Node.js, unless we're using something like Express, which we'll get to later, we can use the HTTP module to create our web server. So the first thing that we'll have to do is to create a variable where we'll store this module, this HTTP module. So we'll have this declaration. We'll declare it as a constant because we're not going to mutate the module. And the next thing we'll do is we'll define a host name and a port that we want our server to listen on. And since we're developing this locally, we'll either use localhost or the loopback address for the host name. And we can specify any port we want as long as we don't conflict with another port being used in our system. 3000 is a safe port to use, so we'll use that. Once we've declared those things, then we can call the create server function on HTTP to create an instance of a web server. And it really is this simple to create one. Now, it's not doing much, but it's easy to create. So let's look at this create server function. We can see that it's passed a single argument, and that argument is a callback function. We've got it declared here as an anonymous callback function, and that's it right there. And we can see that this callback function is showing two parameters, rec and res. We'll talk about those in a moment. And we're doing a few things in here. So what are we doing? Well, the callback function that we specified to create server is responsible for doing the tasks of the server, basically. So this callback function is going to be listening for requests from clients and then responding appropriately. So when our server responds to the client, it generally sends these three things. It sends a status code. And by default, unless we say otherwise, it'll send a 200, which means okay. It sends some headers, and so we might want to set some properties on the header. For example, content type. We'll look more at that. And then finally, it sends something back, a body. And this will be, maybe some text or HTML, or it could be some JSON. So we'll look at what's possible there too. So once we create the server, it's there, it's got a definition, but we have to actually tell it to listen at the host name and port that we want it to listen on. So then we call the listen function, we pass it the port and host name, and another callback function. So this callback function is called once the server is successfully set up to listen on the host name and port that we've supplied. And it's just a way to let our programmer app know that this server is established and listening. So in our callback function, we're just logging a simple message that says our server's running with the host name and the port. And once we have this in our app.js, we have a basic server and we can run it with Node. So let's give that a try. So I've already got this code in a file called app.js, and it looks just like what we had there on the screen. So let's go to our terminal session, and we're just going to run node app.js. And there's our console logged message. It comes back right away. And if we go to a browser now and we try to connect to our server, there we go, it connects. So this is pretty simple so far, right? There's not much to it. We've got a server listening at port 3000 on our local system, and it's telling us hello, all is well. Okay, so let's have a closer look at these arguments that we, the parameters that we have in our callback function for create server, rec and res. So rec is short for request, and it holds all the information about the HTTP request from our client. And we'll have a look at that thing in a minute and see that it's got heaps of information in it. Res is short for response, and we use this response object to pass information from our server back to the client. So some things that we want to notice about the server that we've got so far is that we haven't defined any routes. No matter what we type in to the address bar in the browser, we'll always get the hello world message. So let's just have a look at that. So we can go to the root route, we can go to something called hello, we get the same message. We can go to llamas and we get the same message. No matter what we type in to this address bar, even if we have multiple paths here, llamas are great, we get the same message. So we're not distinguishing in our server right now what route we're responding to, which URL we're responding to. The other thing to notice is that we're not making any distinction for methods, HTTP verbs or methods. So it doesn't matter what verb we're using. If we used get or post or delete or put or patch, we're still going to get back the same message from our server. And that's because if we look at our server, we're just sending back the same thing every time. There's no if blocks in here. There's no logic to distinguish what the client is sending us and to send back something depending on what the client sends us. So we're always sending back the same thing. So we're going to talk now a bit about Postman, because I've told you that we could send over a post and we'll get back the same response, but how do you know? Well, it's difficult to test posts sometimes when we're generating a server, but Postman makes it really easy for us. And so let's talk about Postman, because we're going to use it in this lesson to test our server as we develop it. Now, Postman, there's a link up here at the top and requirements that will let you know where you can get it from. It's an application that you install and it's cross-platform. Here we go. So you can just go to this link and get yourself the Postman download. So I've got Postman installed on my machine. Let's have a look at what it looks like. When you open Postman, a pop-up comes up first that prompts you to create a particular kind of project or session, and you can just close that, and then you get this screen here. So one thing to notice is that we can actually title these requests and save them. So this can come in handy if you're working on a project for a while and you want to set up some requests and be able to use those. So We'll look more at that later maybe, but below that we can see that we have this drop down where we can select the method that we want to use to send a request. Here is an address bar to put in the request URL, and we'll have to include the hostname and port there, just like if we were doing it from a browser. And below that we have a section here for our request that allows us to specify parameters, authorization, headers, a body, a pre-request script, and tests. So we're not going to look at all of this today. We're going to focus on body when we're sending a post request. And then below here we have this section where we'll see a response from our server. So here's where the response comes from our server. So let's just try here. If we send a GET to HTTP localhost 3000 and we send this request to our server, then we see exactly the same response from our server. And beyond that, we have a little bit more information too. So we can see, for example, that we got back a 200 OK status. And Postman's nice. You can mouse over this and it'll tell you what that status means. So when you get something, a different status message, it'll give you a hint if what that status message is. If it's not what you expect from your server, it might help you to debug. It'll also tell us how long it took for the server to respond and the size of the response from the server. That breaks it down for you even if you mouse over. So these are some really nice features of Postman that help us to develop our server and understand how our server is behaving. So let's just give this a try real quick. Let's change GET to POST and send this to our server. And lo and behold, we get back exactly the same response. So we've proven that to ourselves now. And we've seen how easy it is to use Postman. It's quite nice, actually. So that's going to come in handy as we go along here. Okay, so let's continue on. Let's talk some more about this request object, because right now our server isn't particularly useful. It's friendly. It always says hello. That's nice. But we need it to be able to differentiate between the different types of requests that we can get from our client. So how can we do that? Well, we need to figure out how from the request do we find out what the HTTP method is and what the URL is. Those are two important pieces of information. So let's just first have a look just at this request object and see what we're dealing with. So we'll just add a log message to our create server callback function, and we'll just put it here at the top and we'll say console log rec. So we just want to have a look at that object. So let's save that. Now when we make a change to our server, if it's running, if we send another request now, we expect to see our console log, but we don't. There's no message here. So that's because if we run our application with Node, it's just running. So it's read in what we had defined in app.js at the time we ran it with Node, and that's what it's running off of in memory. So if we want it to run with the changes we've made, we need to stop it and restart it. So now if I press send again, it console logs the request for us. So there's a lot of information here, lots of things. And what do we do with all this? Well, at the moment, we're just interested in some things that are near the top here. Actually, they're in the top here. They're near the headers, so not quite at the top. Let's find it. So you can see that this object is quite a lot to look at. Oh, here we go. Where are we? So actually it might be easier if we grab this output. Here we go. This is what I'm looking for. We have some headers, and then here we are. We have a method and we have a URL. These are the things that we're interested in. So from Postman, I had sent a GET, and I'd sent it on the root route because there's no URL past the specification of the host and port. So you may remember from when we did Rails that the URL is the bit that comes after the port. So when we have nothing there, then we're just sending the request on / or the root route. So this is a lot to look at. It's a bit overwhelming. Why don't we just log the things that we're interested in? Now we know that the name of that property, the properties are URL and method. That's handy. Then let's just log those. So we're going to use some destructuring here, which is a nice handy JavaScript feature. So we can do this. We can say, I want the method and the URL. And let's take a look at the headers as well. And I'm going to pull that from the rec object. Now this is just JavaScript syntax, and we'll see it a lot and use it a lot because it's very handy. So let's just give ourselves let's let ourselves know what we're logging here. So we'll say, okay, we got a method and we got a URL and we got some headers. All right, and of course, since we made a change to our file, we're going to have to restart our server. Now let's send that request again and see what we got back. So this is much easier to look at. So here we go. We have our method, we have our URL, and we have our headers. And the only thing I'm going to point out in the headers at the moment is that we can see that this request was made from Postman. So user agent, this property of the headers, lets us know that the request came from Postman. Let's see what happens when we make the request from the browser. So if we refresh this page in our browser, then we have a look at console. We can see that the URL is llamas are great, and we can see that the user agent this time is Mozilla. So we can see the versioning information and some other bits and pieces that could be useful for us if we're trying to tailor a response based on the browser that the client is running in, or where we're coming from. So this is good stuff. We've got the information we need now so that we could distinguish between routes and actions or methods, and we can respond appropriately. So this is great. Now that we have this information, we can use it. So let's talk about some basic routing. First of all, what do we want to build here? Let's build something simple. We're going to build a simple server that has 3 routes, 3 functions. And what it's going to do if we go to the root route is we will, have a list of students. We'll hard code it at first. And if we go to the root route, our server will match 2 students randomly and return those 2 students' names. And we could use this, for setting up lunch pairs if we wanted to. We want the class to meet each other, and so we assign 2 random people to have lunch together. Or maybe for pair programming, we assign 2 people to work together randomly. So that will be our root route. If our client sends a request to /students, then we'll return the list of students that we currently have, and then we'll have a post method action that will allow us to add a student to the list. So when we create a new student, we send a post. If we want to get a list of students or get a match, then we'll send a get from our client. So now we know these are the URLs and these are the methods that we need to handle in our server. And so now we can modify our code to look for these. Now let's start simply, and what we'll do is we'll just look for the get method on the root route, and we'll for now, we won't implement the code to actually match students and so forth. We'll focus on implementing the correct response from our server given the method and the URL. So we'll just send back a simple message that says we're matching students. So let's give that a try now. So we will, here in our callback method, we've got the method URL and the headers. And what we're going to do is we're going to say if method is get and the URL is the root route, then what we want to do is to send back the message matching students. So another point here, we don't necessarily have to set the status code 200 because we know that that's the default. So we could remove that line of code. Currently, and we'll talk more about the content types that we could set in a bit, but we are setting a content type of plain text, and that's the header property that we're setting at the moment. And this is okay for now. A lot of times, our server will just send back either plain text or JSON because our client will decide how to display it. We won't try to send back HTML necessarily, but we might. So the end function that we're calling on the response actually sends the body of the response back. So we're just sending back the string matching students. So now we are distinguishing that this is what we want to send when we get a get on the root route. Now let's see how that changes the behavior of our server. So let's restart it. Now, if we go to the root route, let's check that out. We get back our message matching students. Now, what is going to happen if we try to go to llamas now? What do you think is going to happen? Let's give it a try. Ooh, okay. If you can see here by the little spinning thing on the browser tab that it doesn't seem to be responding. So I can see from my server I've logged that I got a get on llamas and I logged the headers, but it does not appear to be responding. Let's try from Postman. So from Postman, if we send a get on the root route, then we get back our message matching students. If we send it on llamas, we got our 200 status code. If we send it on llamas though, it's even more apparent here when you look from Postman that it's still sending. Well, it sent the request, but it's still waiting for our server to respond. Our server is not responding. So why is that? So let's kill the server. That will kill those request sessions from our client. And you can see here in the browser, it says localhost didn't send any data. We feel quite neglected here. So let's see. Now what's happened, of course, is that we're no longer responding unless the URL that's sent over by the client is the root route. So we are going to have to handle that. We need to make sure that we take care of the case that we get something other than what we expect. So we will take care of that shortly. So before we get there though, let's add a list of students. So I'm just going to grab this from here and let's implement our get route for /students. So I'm just going to stick this array at the top of our file here. And how are we going to do this? Well, we can just add an else if, and we can say else if method is get and the URL is students. Well, then what we want to do is we want to send back the list of students. Okay, so how do we want to do that? What content type should we use to send back this list of students? Well, at the moment we just have an array. So honestly, we could send it back as plain text if we wanted to. We could format it in HTML so that we send back something that's, an HTML string that is going to appear more nicely on the page. But a more practical thing to do if we think forward about how we might use this server is to send it back as JSON. And the reason for that is that from our client, we can imagine that we might want to do something with this data, this list of students. We might want to cache it, for example, temporarily on the client so that we don't have to ask the server for it every time we want to display something. We also might decide later that we want to put more information in this student data. Maybe it won't just be an array of names. Maybe we'll add some information about the last student that this last students that were paired together, or something else. So in order to make our application more extensible, possibly, let's send it back as application JSON. It won't hurt. It'll actually look exactly the same when it goes across. We'll see that, but it'll give us a bit more flexibility. So we can set the content type to application JSON. And so the way we do that is to say set header on the content type, and we'll set it to application JSON. And then what we'll send back in the end function is we'll stringify the list of students. So it's a good practice to always stringify the data that we send back, because this data is streaming, so it goes across the internet in strings, or in streams, which would be we'll see a bit of that later when we look at sending post requests from the client. But we'll stringify our data, and then we know that we're sending it across as a string with data that will be parsable by our client. So now we're taking care of this. Let's see if it works. So what do we have to do first? Well, we start our server. So we'll start our server, and then let's try it from the browser first. So let's send a request on students. Oops, it sent it on llamas. That's not what I told you to do. Let's try that again. Actually, I think it didn't send. There we go. Here we have our list of students. Let's give it a try from Postman just to see that we get the same thing. And then we can also see that we got a 200 back. We have our list of students. And so this is good. So far, so good. Okay, so let's handle now the case that we don't get an expected path, because we might accidentally type in the wrong path name, and in any case our application needs to handle this. So we could simply do that just by adding an else, couldn't we? So if we get something we don't expect, then we want to set the status code, which is a property, by the way, and not a function, to 404. So 404 is the code that we send back when a page is not found. And if you need a reminder of what the status codes are, here you go. We have status dogs. It's my favorite way to look up a status code. And there's 404, not found. So we'll set the status code to 404. We will set the content type to text plain, and we'll send a simple message that says route not found or invalid route or something like that. Now let's just add some logging here so that we know when we look at our server what we are responding to. So responding to get on slash, and this just might help us with some debugging later. We'll log here that we're responding to get on students, and then finally we'll log route not found. And I'm going to do one more thing, and that's just to mute the logging of the headers for the moment, just so that we have less coming across our server. So let's restart our server, and let's see what happens now if we send a request on llamas. There we go. We get back right away a route not found. We can see from our server that we went to the llamas route URL and we got route not found. We can test the same thing from Postman. So we send that request and we get a route not found, and there's our 404. Beautiful. So fantastic. Look at this. We have a basic server working. We can handle our GET request. We still need to implement matching students. We'll do that later, but we have a really good start now. Now, before we go any further, we'll have to talk about npm init, node modules, and package.json just to make our lives easier as a developer, and that's what we'll do next.